Imagine that someone told you to think of an example of mathematics that was also beautiful, like a painting or a Mozart composition. Math, you might think to yourself, math is proofs and equations, numbers and decimals. It might be useful, but beautiful isn't the word that comes to mind when describing it. Well, what if I told you that there's a place where the world of mathematics and the world of art overlap, by never overlapping? Have you ever seen a honeycomb? Bees use six-sided shapes called hexagons to make their hives fit together. Why do you think they use this shape? Why not a different shape, like a circle? Well, if you think about it, a hexagon is a very useful shape because it fits together with other hexagons perfectly. A shape like a circle would leave gaps. Shapes, like those made with hexagons, squares, and triangles, aka polygons, have the ability to tile, or in mathematics, to tessellate, meaning they can fill a flat surface or plane with no gaps and no overlaps, repeating forever in all directions. Historically, tessellations were used in art and architecture due to their decorative beauty. Ancient Sumerians used clay tiles to compose tessellated decorations for their homes and temples 6,000 years ago. The Egyptians, the Persians, Romans, Greeks, Arabs, Chinese, they all used different forms of tessellation as a way to decorate important spaces. The word tessellation comes from the Latin word tessella, which refers to a small stone of tile or glass that can be used to create a mosaic, the original way that most were designed. The work of Dutch artist M.C. Escher is especially notable when it comes to combining mathematics and art. Escher was a graphic artist in the early 20th century whose art played with mathematical operations like impossible objects, reflection, symmetry, perspective, as well as a special focus on tessellation. During his travels in the 1920s, he visited the Alhambra Palace in Spain, where he became fascinated by the elaborate geometric tiling. Although he created many interesting types of art, he always returned to tessellation, creating 137 in his lifetime. Escher went on to describe 3 ways of moving his shapes to create tessellations. The first is a translation, where the shape repeats by moving or sliding. The second is rotation, where the shape repeats by rotating or turning. And the third is reflection, where a shape repeats by reflecting or flipping. Now that you have some examples of Escher's work and an idea of what a tessellation is, go ahead and take our Is it a tessellation quiz and see if there are any gaps in your tessellation knowledge.